Hey, welcome early arrivals. Welcome Arthur. Welcome Ashkan, Gilon, Joe, Moti. Welcome. We're gonna take a couple of minutes to let everybody join us, and then we will get started. Welcome Pablo. Welcome Serge, Snir, Bubbles. Welcome Ken and Jason and Arslan. We have 260 people registered to this webinar, so it will be a packed discussion today. Welcome Ashkan, welcome Wojciak. Hope I pronounced that correctly. Amin, Nicola. Welcome Daniel and Chi, and I think we are ready to get started. So welcome everyone. Like I said, this is going to be a packed discussion. The title of this webinar is Conquering the Complexity of Self-Hosted Apps with Agentic AI SRE. Just a reminder that this session is recorded. We will share the recording and the deck with everyone who registered. So don't worry if you missed anything. If you have any questions throughout this discussion, feel free to drop them in the Q&A below, and we'll get to them either at the end, or if it works out, we'll answer them live at the moment. So without further ado, let's get started. So today we are going to discuss the many challenges of hosting a SaaS product on different environments. And if you are working at a SaaS company, if you are working in infrastructure, if you've ever been on call, this webinar is for you. And to talk about this, we have Michael and Nir, two very smart and experienced people for this topic specifically. So Michael, Nir, please introduce yourself. Tell us who you are. What do you do?
Hi, everyone. So I am Mikael. I work for the past 5.5 years at Komodor as the R&D tech lead. I come with over a decade of experience of managing Kubernetes clusters and infrastructure, as well as architecting high-scale applications, mostly like in the backend and data pipelines.
Introduce myself, I'm Neil, part of the CTO team and the AI team, working on Klaudia. It's our own agent that doing all the investigation and self-healing and all of those AI integrated flow in the system. And happy to be here.
Happy to have you both. Definitely the best people to take this discussion. And so let's get started with the basic. Let's set the stage for this. So what's the big issue with self-hosted apps? What do we even mean when we say self-hosted? Who should even care about it? And who is this for?
I can start with that. So let's start with the not so obvious what are self-hosted apps, right? So it can mean a few different things. And in the context of this discussion today, self-hosted applications are basically, say, we are a SaaS company, right? And there are some of components that will be necessary to deploy on-premise on, like, for example, a customer or a user's own Kubernetes cluster, right? This is kind of a standard patterns as known as like Kubernetes operators or Kubernetes agents. And this is mostly what we're going to focus on today. And the main or our core issue that we experience with these kind of applications is basically, as a SaaS company, you ship one product, something that one platform, one product, something you try to keep kind of integrated. But what happens in the end is that because we have the necessity for this Kubernetes operator or agent, it then runs in hundreds of different environments that we don't control, right? As the company that supports this application. And at the end of the day, there's a lot of difficulties that come with that, right? Might be just the burden of supporting these many different environments and require multiple different peoples, right? You need support engineers, you need platform engineers, you might need SREs, you might need communication with the person handling this environment to kind of understand all the differences and all the issues that might arise. So then, we could say, right, there are finite sets of different ways to deploy things on Kubernetes or things we can run on Kubernetes. Isn't this just a documentation thing, right? Can we just document most of the things and for 99% or 90% of the cases cover, right, similar things? The answer is very complex, right? Of course, you can have most people run, for example, a Kubernetes cluster on a specific cloud provider, right? And on the same version and using the same configuration, like base configuration for the cluster. But then they will install your application or like your Kubernetes operator, and it will behave differently. And it might be because of networking, because of scale, because of security requirements, because of multitude of different things that might differ for every user, even if they use the same base environment.
Okay. So, Mika, let's talk more about how environments differ. So we understand that there's a problem, and obviously each environment is widely different. But can you go into specifics a bit? And Nir, feel free to jump into it as well. Share some specifics on what exactly is different about each environment and why is it problematic, and if you have any real life stories or examples of how it plays out in various scenarios, then please do share them with us.
Yeah, I definitely have hundreds of war stories, as we call it, from being on call and kind of just troubleshooting things over time. But we'll get to these when it makes sense. So in terms of like specifics of how environment differs, there's really a lot, right? It might be Kubernetes version itself. It might be different plugins you might be using, like CNI, like networking plugins or storage drivers. The different underlying nodes architecture, the size of the machines you're running on, different permission schemes, like configuring like RBAC and service accounts for your different needs in security needs in the cluster. And at the end of the day, if you're installing a Kubernetes operator, most likely it's going to use a service account attached to a cluster role, which are predefined set of permissions of what it can actually look at, read, do, act on your cluster. And it makes complete sense to do that. But then everybody can obviously choose to allow some things and not allow different things. And then it might affect how that operator behaves, right? Or what it can do. Other most likely things that might cause issue are networking, whether like network policies, different uses of proxies and DNS configurations, different cloud providers handle networking slightly differently. On-prem configurations might handle it completely differently. And that becomes like a huge black box of things that can happen, right? So for example, like a real life example, we have a customer that uses a non-standard CNI, so a network interface, like Calico or Cilium or things like that. And basically, every communication that happens inside the cluster, even pod-to-pod communication that happens inside the cluster, goes through that networking interface. And depending on how they configure that, depending on how they use it, it might cause communication to just fail. And then our operator would try to fetch data from the API server or communicate with a different pod, like a different component of our operator, and just randomly fail. And you don't really know why, right? You just get a generic connection refused error, but you don't have more than that. And then you need to dive deep. First, you need to understand you even have a different network interface. Then you need to have the ability to kind of read its configuration or its logs to understand there even was an issue there or that network is passing through it. So it becomes very, very low level, very intensely.
But
I think every cluster is different by design, right? Every deployment that you are doing on your cluster probably look different because you need to adapt it to your need. So each company has their own needs and their own stack of technologies, so it's look totally different. And you need to know how to live in these different differentiations that you have in each of one of them, and to know how to act, how to for example, you give the network also proxy, right? There's lots of customers that using internal proxy if you want to go out. So that's an example that you need to know how to handle that if you want to give service to these customers. And it can be so different in each of one of them. And that's basically what creating the problem that we are talking about.
Yeah, it's a bit similar, I think, in mind with like development and staging environments, whereas you're always aiming and trying to have something as similar as possible to production, right? Because that's what you want to test and that's what you want to validate. But in the end, there's always going to be some kind of a gap. For example, any possible configuration that you might do. Let's take, for example, I don't know, like storage, right? Let's say you have three different modes of like read access for your volume. So you would have like read write once, read only, read write many, and all of that. And then for that storage class, you also have like different variables and annotations you can put for the specific driver you're using, right? So even these 5 variables with 3 different read options each present over 200 possible configuration just for that one component, right? And combine that with every infrastructure component that you have on a Kubernetes cluster, it becomes a monstrosity.
Endless.
Endless, yeah.
Yeah, a monstrosity sounds about right. But tell me, what about monitoring tools? We at Komodor have monitoring tools. Our customers use monitoring tools. Shouldn't that solve the issue? Shouldn't we know exactly what's going on all the time?
Supporting all of the options of monitor tools, there is like thousands of monitor tools. So you still need to know how to work with all of those options. And even if you monitor, you still have lots of, for example, network. It will be hard to get out if you have network issue, right? So you just don't see those metrics. So there is lots of issues, even if you try to monitor everything.
You might have like different naming convention for how metrics are even like sent. You might not have access to them, like Neil said. You might have different providers of observability or like monitoring tools. Even like in the open source community standards. Today you have OpenTelemetry, but even with OpenTelemetry, before that you had I forget what the name was, but you had something before then, that was also the standard, and then it moved to OpenTelemetry. And then inside that, you have different versions that, some have breaking changes and send things a bit differently. So it's, every case is best solved individually, right? By understanding what you actually have access to. So yes, we have metrics on our own operator, obviously. And we can get access to that, but in the end, there are some things we can also not collect, right? Or
You
things
can cover
that,
everything by
yeah,
default,
we
right?
just can't cover everything. The first step of monitoring efficiently is knowing what you need to cover. But then because there's so much of it, it's hard to.
So this sounds like a never-ending loop. The more you try to add tools to help you to simplify things, you end up adding more complexity, more divergence, more fragmentation. And so what do we do about it? How do we overcome it at Komodor, and how do other companies in the industry do it? Sure, there are various approaches to this. So maybe don't start with Komodor, start with other vendors,
Mhm. Do you
I
have any
think in
stories?
general, you first need to prepare, right? You need to understand what is the possibilities that you are going to face, how it's going to look like, what it will be the differentiation that we need to put, like, to be prepared and to be ready for it, right? If, for example, we talked about network issues or different cloud or even Kubernetes vs OpenShift, like all of those differentiations that you need to go and be prepared for that. So if I'm creating a deployment for my agent, so I will go and check it. For example, I will check it on Kubernetes, I will check it on OpenShift, I will try it on different clouds, and I will see what is the behavior, what is the weak points that I need to see, what will break my agent, and collecting all of those tests before I'm going to deploy on my customer. Basically, I will come more prepared and I will have more success because I prepared, because I collect all those information, and doing all of those experiments make our deployment more resilient and more option to succeed.
Mm. I completely agree with all of that. And I just want to add that there is a real observability fatigue, right? About collecting data, right? You can say, of course, like I need to collect as much data as possible because then I will have what I need to troubleshoot things. But it's very, very, very easy uh, to have that cause um, even more problems for you because then you have a lot of data that you don't really need and you don't really know that you don't need. And it makes everything more complicated to look at, right? So the way I look at it, for example, and it's obviously something like I've learned over after failing multiple times doing that, um, but it's to think of observability as like a product, right? You need to think, what is my application doing, right? What are the user stories or how will it behave? What are the flows of my applications? And for each one of them, try to answer a very simple question, right? How do I know it's working, right? So for example, let's say I have an operator, right, that kind of collects and sends data to an API and kind of pipelines that. Um, the easy answer to that is just, am I able to send data from this operator, right? And if not, then I have a problem, and this is the thing I need to focus on, what data to collect to understand why can I not send data. Everything else is irrelevant.
I think it's also cost. Like you don't want to send all the metrics in the world. It's also you don't want the customer to pay on the network latency, and you also don't want to store too many data. It's also hard to go and do something if you collect too much data. So I think you prefer by design to make the agent in the customer environment to be lean as possible. It's
Mhm.
also reduce the friction so you have better success because just less code, less bugs, right? So it's intentionally that you're trying to be small as you can, and that will be more efficient and more resilient just because less moving parts.
Yeah. I think you're right. Like it's there's a lot of cloud solutions for monitoring that will gouge you in terms of pricing for sending metrics, right? And then you always start thinking, do I really need this? I'm not sure. But then you're missing data and all that. It's a hard battle. Um, and i- you also need to take into account like the human cost of it, right? You're gonna have observability and dashboards and monitors and run books and whatever. But you also need the people that know what to do with that, right? And if you make it too complex and you send too much data, you will either spend more time trying to read the data or spend more money on somebody that's more experienced because he needs to know to read that data instead of something or of sending something that's simpler but effective. Um, and I think that takes me right to kind of the what tools we can use to make uh, to overcome like these observability challenges. Um, and I feel this has also evolved like in the last couple of years, right? Before then, you had a lot of dashboards, a lot of run books and scripts that you can kind of you build your catalog in the company. And whenever there's something that there's an issue occurring, something is not working, you refer to some kind of documentation, some kind of run book that kind of uh, makes you follow step by step what to look at, what to check, how to kind of dive deeper into something to understand the root cause. And I feel now this has changed a bit, right? And we have gotten to more automated things, to AI, uh, which at the end is kind of, similar run books, just better in my mind.
Mika, before you dive any deeper, I want to stop for a second to answer a question from the audience, from Serge. And this is the answer would also be a good wrap up for this slide generally, and then we can move on more into the solutions and the way AI is transforming things for observability. So Serge is asking, what are the main observability challenges you encounter with? So let's answer that real quick, just a few pointers to sum up the observability challenges.
From my side, I would say, first of all, not all our customers have all of those metrics that we want to collect. So that's the first issue. There is still different stacks on how they expose those metrics and what the general technology stacks that they are using. So it's still a challenge to know how to connect to all of those options, how to collect that, how to do it in scale, all of that, collecting all of those observability metrics from all our customers. So that's becoming an issue, right? Because now we need to do all of those for one customer, it's not a problem. To go understand how he's exposing his metrics and just scrape the metrics that you interested in and build a dashboard like you just said, that's easy. But when you need to do that to a lot of customer, now how do you store it? How do you manage that? How do you ingest all of that data to meaningful insights, right? How do you use those metrics that you already collected? So that's the challenge that become when you go in scale.
Yeah, scale is a difficult thing. From my side, I think it's the unknowns, right? Because like we started to say a bit earlier, and I think like we kind of jumped the boat a little bit, but it's we try to prepare and we try to think of, okay, what will we need? And we implement that as observability. But in the end, there are unknowns, right? There are things that I don't know that we need. And then when it's something that is out of our control and is installed on a differently managed cluster with a customer that might not always be responsive, like in real time to kind of upgrade and answer questions, you just stay in the dark. And that's a big challenge.
Okay, I hope this answers Serge's question. And follow-up question for me is, what's the most creative workaround you've ever deployed, or the most creative solution you found for this problem from your work at Komodor?
I don't know if creative, but it was a very good solution that we use to this day, right?
I'll
We
take it.
we had an issue with our agent that basically resulted in a memory leak, and it happens to the best of us, and it's very hard to figure out. And it's resolved by then. Don't worry. But yeah, and like we had observability, we had data, but it's something that's very hard to reproduce, or at least it takes a very long time. And then, with the nature of Kubernetes, that it just there, and the if you need any logs, any events, anything like that, they just vanish after a while because Kubernetes doesn't keep them, or like the history of it, for a very long time. So what we did is we added a second container, like a sidecar basically, that we call the supervisor. And it basically watched the main container of our agent. And whenever it crashed, we immediately collected logs and metrics and like heap memory data and all of that. And we created like a crash report, which basically was automatically uploading to an S3 bucket, so we can troubleshoot later. So when we get an alert eventually that something is not working properly, we have that extra data that even if we don't know exactly what we needed, we have the raw data, like all the logs or the events, the state of the cluster, was there like any node pressure, anything that might impact. We can get like a trend and graph of usage of the agent at all this time. And this really, really helped us. So basically, the challenge was we didn't know exactly what to look for. And I said, I don't know, let's get everything.
That is creative, I think. Neil, do you have something interesting to share
Yeah, I
before
will
we move
give
on?
examples from my previous company first. So
Okay.
we also had an agent, also deployed to Kubernetes environment. Lots of security, compliance, and stuff like that we need to. My previous job was in Palo Alto, so it's very big companies, very isolated environment that needs lots of ways if you want to go out. And basically, we try to create a more generic approach to the agent. And basically, it's very hard to go and update the agent, right? It's very hard for the customer, it's very hard for us. Upgrading the agent should be a rare case, probably just for security fix. That's an ideal, right? It's not, in reality, it's probably more than that. But you should try to put the agent in a way that it will be lean enough, but generic, that you can use one feature for another. So I think if you plan that and you understand that it will be very hard to ask the customer to upgrade, especially if you have lots of customer and each one of them have a different agent version, it's hard to track. It's hard to know what feature that we are adding will work in each customer. So I think that's something that I always plan for when I'm designing an agent. And also in Commodore, again, the way that our agent is flexible enough that when I'm adding a new feature that we didn't know that we will add when we develop the agent, and we can still use the agent for those features, I think that's what helping us to go forward without those issues that we just said. For example, each customer with different version, and basically, how do you know what feature to open to this customer? So that's something that you need to plan ahead. And if you do that correctly, you will have easier job on adding new feature and making life easier.
Cool. So this is a good segue into the next discussion on what would you do differently, or how to avoid those things that you have experienced and got burned from.
Yeah, so
Um,
we
yeah,
gave a little bit hints, right? Like be
mhm.
lean, try to be flexible. If not every feature that you add, if every feature that we add will cause upgrade in the agent, you will be very slow, and we don't want to be slow. So I think that's a very big planning before you release an agent. You need to understand, does that take me to the future feature that I'm going to add? How do I handle that? You're going to have a different version in each customer. Like that's real life, right? But you need to understand how to work with that, how you understand which agent have which version, and how our application is going to react to that differentiation between of those versions. So I think that will really help you go forward and go fast if you understand the feature. Does my agent support those future agent features? And basically, even if there is different version of agent, how do I still go fast? How do I understand that? How my platform basically react to those different versions?
Yeah. Um,
Mikhail?
yeah. So I guess we jumped the boat a little bit in previous slides where we kind of gave you hints for all of that, right? I think if I gave like maybe 2 or 3 tips on how to design better from the start, and it can apply to any application that you build, and it's more relevant, of course, for like self-hosted applications, but it can work for anything. So one would be um, to have the application designed for the unknown, right? Like we said, every environment is different. There's a lot of unknowns that we don't know about, and this is what makes our life difficult troubleshooting. So designing for the unknown means collecting environment-specific data, right? We can kind of get a fingerprint of the environment we're running on, all the different versions, all the different components. So when we go to troubleshoot something, we at least have an idea of what is happening around us. Second thing would be to have modular architecture, right? It's a bit similar to the creative way that Neil explained they did at Palo Alto to design around using the same features for different purposes. And it's a bit of that, right? If we design the architecture in a modular way, we'll be able to reuse some components, we'll be able to um, um, uh, change how we use things, right? Via configuration, for example. Um, and lastly would be to build observability as a first-class citizen in your application, and not something not like the afterthought of, oh, I'm having issue, I need to handle observability, right? It's something you need to build from the start and think really about what you need. And if you combine that with the modularity of your application, you can make it so it's very, very easy to add new metrics, to add new logs, to add different things you want to monitor. And then you might not even need to get assistance from a customer and ask him, oh, can you upgrade to this version because we want to have this and that data? No, you can do it yourself. I think these are the 3 pillars of how to design something for gratefulness.
One more thing, one of the biggest, I think, outage, I think it was CrowdStrike. So it basically agent update that broke Windows machine. So I think, for example, do like add testing that deploy your new agent version to each of those environment that you know that your customer have, and probably solve many, many issues in the future.
I think sometimes like it's the default in my head to think, oh, of course everybody has like metrics testing over different version environments and everything, and that's like what you should have, but it's hard to
Yeah,
do. So it's
yeah,
a good point to bring up.
yeah.
And what about context? How do you inject context into every scenario that you encounter? Or is that part of having observability as a first-class citizen?
It's obviously a first part of it. Like I said, having a good observability in my mind, means having easy observability. When you develop a feature or add something in your agent, you don't need to think too hard about how I'm going to monitor this. It just needs to happen, right? And that might mean adding context automatically, like having a request ID in everything that happens. So you can easily follow logs, right, of a specific flow, adding user context if it comes from something is initiated from different users or different service accounts, things like that that can really help you kind of scope down the data you're looking at.
Neil, do you have anything to add to that before we move on?
No.
Okay, so now moving on to what is on everybody's mind, AI, and we're gonna talk a bit about our own evolution as a product from API-driven SaaS to agentic SaaS. And I think, Neil, you can start with sharing a bit about our journey at Komodor.
Yeah, first I would just talk about the obvious difference, right? So first of all, usually in the traditional API, we had to have to know all of those, right? We talked about going and checking all of those environment, how they are different and how we are going to behave in each of one of them, right? So that's the traditional way. You need to be 100% prepared. And in agent, it's a little bit different. Why? Because the agent have its own capabilities, right? He's smart. He have all of those information. He knows what is Kubernetes. He knows what is OpenShift. So if you ask a question, the agent on those environment, he can answer most of them if you're asking about like Kubernetes question or OpenShift question or AWS question, you probably will get an answer just by giving it to an LLM. Okay? But in API, you have to know all of those questions answered before. Okay? So that's the bare bone different. So now when we are going to the agent phase, I would say, so we just need to give it the right context that is missing, and she will know how to answer. So those context is the all of those difference between those clusters that we talked about. So the agent know to answer general question about most of the tech that is already knows, but each of the environment have their own constraint and tools that they're using and tech stack. So if you give this context to the agent, it can give you the right answer. For example, if I use Calico and I have network issue, if the agent know that I use Calico and I have network issue between two services, he will know to do the next steps. He will say, okay, he used this tool. That's the environment he live in. This is two services that can't communicate. I need to check, okay, let's see the network policy. Let's see who's talking to who and what can block this communication. So that's the evolution. Instead of doing all those if else and know all of the possibilities ahead and encoding that, we basically preparing a context that we are collecting for the agent, and the agent usually is deciding what of the data he need to collect. Okay, the agent usually have the bare bone prompt that we give it, that what is his mission. Okay, in our example, it's AI SRE, right? So that's the main mission, and he have lots of tools that he can use and sub-agent that he can call. And all of this is the tools that the agent have to complete the mission that we give it. So we can go and collect, okay, what is the tech stack? What is the issue? What is the last logs that show an issue? And basically collect all of this. And if you combine the right context, it can always give you a good answer. That's a very high possibility that you will get a great answer if the agent can collect the right context.
I feel like the shift from API to agents is the real thing is basically the contract differs, right? Before that, we had predefined APIs, like you said, that we know how to call because they're like documented. We know exactly what parameters they're requesting exactly how the response is going to look like and what data we're going to get. With agents, you suddenly, it's more of like of an open conversation, right? You need to know what to ask of it and how. And I think like my question to you, Nir, is how can we prevent scope creep, right? Because you said like we have a high level mission, right? We are an AI SRE, we need to fix a problem, and let's get this and this and this and this data for context. But it's very easy, I think, for an agent or like an AI to have too much context, and then it makes it less reliable, right?
Yeah, and also the context is limited, right? We don't have
That's true. Yes,
endless
you
of
also
context.
you need to scope it at some point.
There is two problems with big context, okay? One of them is just the limit that you just can't send more context. That's one. And the other one is just the agent will be confused. It's like person that you give it a book and then ask a question on a specific page, but he have all the book around him, okay? So it's just too many data and you need to focus him. So you need to take those two problems that we just mentioned and try to give tools to manage it. Okay, so how do we manage? First of all, we have sub agents. Okay, sub agent is basically the main agent will ask a question, another agent, and this agent will handle his own context. Okay, so the main agent context is staying clean, and the sub agent context is going to, for example, to read a YAML in of resource in Kubernetes. Okay,
Which
so
can be
it's a
very
long,
large.
yeah, so it's pretty large, exactly, but it's taking the context only of the sub-agent. And the sub-agent mission is this YAML. Okay, so basically scoping a smaller task in a side agent that doing just that, keeping us the main agent context clean, and also focus, right? The main agent ask a question, the sub-agent go and find those resources that have issue and find the logs relevant, give me the final answer. Okay, and the main agent stay clean and just see the results of those sub-agent, only the resources that you need to focus on and the logs that show an issue, for example. So this one, and also the option to do it dynamically, right? So we talked about that when the agent is awake and starting the investigation, is starting almost like clean. We do have lots of optimization. We try to give it a background. It's just making the investigation faster, right? So we do give it some context right away. But the agent usually go from that point and start to query and do tool call. Go and see what is the resource that related, what what issues they showing, what is the status of each of them. So doing those things dynamically basically keep the context relevant to the investigation that we are doing.
Mhm. Yeah. And I think yeah, sorry, Udi.
Yeah, no, go ahead, Mika.
No, I was about to say it's also very easy. Like in my mind, I'm still, for the past 10 years, I've been troubleshooting things as an SRE or a DevOps, manually, let's call it that way. And then I'm trying to think like, as we move through this phase of agentic options, what exactly like is the difference between having an AI agent that helps us troubleshoot that compared to like a runbook, right? That also kind of basically lets me, right, be the AI agent and tells me what to do step by step and what data and context to give. I think that the main difference between these two is that a runbook is limited, right? It's a bit like having an API. At the end of the day, you have a specific number of steps and they need to be predefined and you need to know about them. But like with observability, there's like the unknown unknowns that we couldn't have predicted that the agent, the AI agent, will be able to continue talking through these layers and understand that it needs new things, right?
Yeah, can take more time, but it can
Yes.
definitely be more adaptable than a static handbook that usually solve
It,
one thing.
it takes more time to like do these extra steps, but in the scope of everything, it takes less time than actual human troubleshooting, I would say.
Definitely. In scale, you can use many agents,
I
basically.
know.
And you are
I'm just
one
trying to
person that,
pinpoint. You say it takes more time, but it depends how you look at it.
yeah.
So would you say that the agentic approach is more like extending your team, like having more SREs working alongside you versus just a simple run book?
Yeah, a lot of sidekicks for your team, and also it's reducing the right. There is lots of, for example, there is developers that just don't have permission, even if they want to investigate their issues, or they just don't know, for example, Kubernetes. Okay, they know their own application. So for all of those questions that basically the agent can answer them in a very high capabilities and just let you focus on your own work. So that's giving you a lot of free time to do the actual work instead of doing all of those tickets that people is opening for you to handle their own
Mm.
issues. So yeah.
Yeah, usually like before that, it resulted in a lot of context switching and just kind of locking you to having to be more cooperative and answers a lot of questions. Whereas now it just takes that much load off of you, right? It's still cooperative because you can still kind of uh, uh, get brainstorm ideas with your coworkers and colleagues, and you still work together, but it just makes it easier.
Yeah, we're going to talk about this more in a minute, but we also give the operator, right, the SRE itself to improve the agent, right? We are trying to learn from the SRE and becoming better and better SRE agent ourselves, and basically all those tickets and like boring tasks that the SRE is doing in his daily, he can now delegate to the agent. So making their life much easier and better.
Hopefully, yes. So let's jump ahead to the solution, I would say, or at least part of it. So we talked about the classical issues from like a traditional DevOps perspective, and then we talked about the new problems that emerge when we're moving into more of an agentic approach, which solves a lot of things, but also introduces other problems, newer problems, and we've established that an AI agent is only as good as the context you give it. So how do you give it the right context when you have thousands of different environments that they need to operate on?
Exactly. So we talked about the general issue, right? That every environment look different. So that's the context that we are talking about, how to give the agent the best capabilities and context that he can collect and get to work in those agents. Okay, like we talked about static runbook. Okay, so we want our agent to be dynamic, right? To be adaptive, to be better in each environment by understanding what is the stack, answering those questions that we are asking. What is the stack? What is the tools? How do I collect the right logs? And what is the resources that related? So answering all of those questions, that's the context that we want to give to the agent, and that's what he needs to give the best answer. So we talked about the static, the mission, right? The agent have his own mission and he knows his own tools. But this is very like this is the generic way, right? This is correct for all our customers. But how do we adapt our agent per customer? So that's the more dynamic approach that we are going to talk right now. So we have two options that we are giving. One of the option is similar to what we're doing with Cloud Code and Cursor, all those Cloud MD file and Cursor rules and skills even. So we basically combine all of these features and adding to our agent because we know that's like the best way. So we have a feature that's called Blueprint that's similar to Claude MD. You just explain in it's a one pager for your environment. Okay, what is the tech stack? What is related to what? If you have a custom CRD, we have customers that created their own CRD. So the LLM can't know because it's like it's a specific thing. So if you add to the blueprint, what is just the name, right? This is our CRD, this is how they connected, this is connected to this. And just knowing this connection and what is the tech stack, it's also make the investigation faster because the agent don't need to figure out those things himself. And also, um, there is some stuff that it will be too hard to know, okay? Because it's specific to this customer and it's not a known thing. So that's what's solved by Blueprint.
Yeah, and to add to that, and to also answer a question, because why not? We can also, in the blueprints, provide existing runbooks, right? Each company already have some runbooks of things they know how to fix already. So we can tell the AI SRE, listen, these are the things that we already know exactly what to do and how to fix. So instead of spending that much time investigating, you can just do these steps, right? And this is something, of course, like this is the definitely like the minimum capability that an agent should be able to do. And from that, it will also kind of learn itself and provide more context for different things.
Yeah. So now, when I'm talking about dynamic and static prompts, the blueprint itself, I think, usually is static. Okay, you build your environment in this one pager. It shouldn't be that big because you add this blueprint to each session, and you don't want it to take too much from the context. So the blueprint shouldn't be that big. Okay, for the other stuff that you want to add, that it's more in-depth and documentation that you have for your own developer. So that's the second feature that we have, that the knowledge base, right? We basically connect to your knowledge base tool. I don't know, Notion or Jira or Atlassian or whatever, connect to your solution and basically read your own documentation. Okay, the agent, by reading your own documentation, can find runbooks, can find how did you solve the same issue in a different, if you're doing a retro on issues that you have, and add those to your knowledge base. So if the agent query those, it can solve issues, right? If it repeat next time, even a similar issue, right? So it can correlate those knowledge that you are already added and solving issues by reading them.
Yeah, I think having that exactly what you said is exactly the difference between, for example, having someone on call that is newish to the company, right? Like the past 6 months, versus having a senior team member that's been in the company for like the past 5 years and has his own armada of of incidents that he already fixed and know exactly what to look through. So these blueprints and connecting it to a knowledge base is basically empowering you and giving you these 5 years of experience for like almost no cost, or like at least it makes it worth it.
Yeah, also for the agent, it's much easier also to swim in this knowledge base, right? Because usually, at least from my experience, the knowledge base
It,
can be huge, right?
it reads
It's
faster
hard
than
to
me,
track.
for sure.
Yeah, it's hard to track. It's hard to find what is relevant and what is not. For agent, it's much easier, right? We use vector database today, like so there is all of those connections. So for the agent to find an answer instead of me going and searching like text-based search, it's it's just much easier for him. So asking him my question, and he will go and collect those my environment, right? He have the tools, he can query my resources, he can go and see my blueprint and see by dynamic querying the knowledge base, what is the relevant data he can get from that. And if you combine all of that, right, he can see my environment, he knows how it's look like from the blueprint, he knows what past incident look like from the knowledge base, and he have my question. And if you combine these two, that's a very powerful thing that will help the agent find issues and even just answer a question, right? I'm a new employee. How is my environment look like? Create a diagram. Like, what is the database that I use? Like that, like to do that myself will take a lot of time, but for the agent, it's instantly.
Before we move on, we have a few questions from the audience, so we're gonna stop for a second to not keep everyone up. So Patrick is asking, does your agentic AI implement any proactive SRE capabilities, or are there any plans to support this in the future?
So yeah, definitely we do
That's
have
it.
proactive. Yeah. So yeah, we call it self-healing. I think that's there is two parts, right, for it. So first of all, you need a good trigger. Okay, the good trigger in our system, it's violation that created. When a resource status is degraded, you have a violation that's open automatically, and that's the trigger that starts everything. Now we start an agent, the SRE agent that doing root cause analysis and basically find what is the issue. Okay, that's the first thing, and it can be automatically. From this agent, he passed the job to the next agent. That's the remediation agent. The remediation agent will find how do I solve it. Okay, I understand what is the issue, but there is many ways to solve those issues. And also you have like immediate solution, like changing something in the resource. And you also have the long term to fix the bigger issue or even create a PR commit that will keep the change after the CI. So there is many options that you can go, and we do have support for that, that will be self-healing and do that automatically.
Yeah, and I think that also answers Serge's question, saying, what's your take on Gen AI being a robust option to proactively detect issue patterns? So yeah, I think definitely this is
Yeah,
our
I think
approach at Komodor.
that's machine learning and Gen AI are like a subset of AI in general. Machine learning can obviously help you detect patterns and issues, but then how do you fix them, right? It can tell you there is an issue, most likely or with a probability, but then Gen AI is able to give you also why and how and what to do.
And this is something that we may have glossed over during the discussion, but Arslan is asking, how do you make sure it doesn't trespass and screw up everything? Very valid question. I think guardrails and permissions are things that are super important, and you can share a bit about how we do it at Komodor with Klaudia, our AI SRE. Neil mentioned the self-healing capabilities, so this is definitely something that people are very, very scared of at the moment, letting AI agents run autonomously and make decisions on their own. So real quick, how do we make sure that they don't screw up everything?
Yeah, very valid question. So there is two parts, right? First of all of our customer can choose. Okay, it's not like out of the box and we just do stuff in your environment. It's really not like that. You can create a policy that says exactly what you want us to self-heal. Okay, we go investigate, but when we do the action, we see does this customer allow this action on this cluster, on this resource? You can fine grain, right? With some cluster you want, with others per deployment. Okay, so you can choose specific what you allow and what you don't allow. So that's one thing. The other thing, we talked about a little bit about short-term solution and long-term solution. So it's also here. So some of the short-term solution, for example, I don't know, a pod that is not scheduled, but if you delete this pod, it will schedule on a new node. Okay, for example. So it's not, there is no risk here. If it will not solve the problem, the pod is going back to the same state that it's stuck. Okay, so that's an example. And we, when we finish the remediation, we go and check. Okay, we keep in a loop and we still checking, do we solve it or not? If it's not solving, we can roll back. Okay, we are using rollback a lot. Usually when it's safe, you do want to use rollback just because it knows your environment, right? If you have one service that depend on another service. So rolling back and using, for example, the Argo CD, deployment. So it's much safer to do those manual changes in specific service that maybe will solve this service, but the other one is dependent. So yeah, combine all of that is basically what would give us the more confidential that we are giving a good solution. And we know that the agent will monitor and see that it's not screwing up and fix it or rolling back. So yeah.
Yeah.
Mikhail, any thoughts?
I mean, I think Nir is more knowledgeable there than I am, but I'll add that we obviously also uh, have a human in the loop and kind of validate every change and thoroughly check how our AI, sorry, how our agent is behaving in under different circumstances and environments. And so every time we do an upgrade to it, there's like a long list of things we check for, right? So in addition to all these automatic guardrails, there's also like the human element, which gives that last okay.
And we are almost out of time, so I'm gonna move ahead to the final point of today's conversation, which is what's the next stage, or what does the future hold for AI SRE, for agentic AI in general? And with that, we will conclude. But before we do, anything else you want to add on this topic, on blueprints, knowledge base? Any last thoughts?
I think we've covered it.
Yes, Nir, you agree?
Yeah.
Okay, so let's talk about the next phase.
So yeah, the future is very interesting and very exciting. I think the agent will go and be better and better, and they are already very, very good. So yeah, we're definitely going to see more and more agent in every part of our life, and especially in in our environment. Um, so yeah, we're going to focus more about how we making the agent better. So we have basically building an agent for feedback loop and learning and creating a memory, a long time memory. So we collecting the chat and the RCAs and how you go and when you go and solve issues by yourself, and we can track that. We also can learn with that. So collecting all of those things and creating the memory for us. For example, we talked about the blueprint and knowledge bases, right? The problem with those that it's hard to maintain because every time I have new stack, new technologies, new issues that appears, and they are not there, right? Because they are new. So that's I think where the future is lie. We're going to collect this and create an active memory and learning from past incident when they occur, and then the next time we're going to have that. So we're going to approve our own context much better and learning from that and combine that with better models. I think we're going to have a much fun time and we're going to focus on the actual work. I think we are going to lean more on designing system than actually maintaining them.
Mm.
Mikhail, your thoughts? What about maybe talk a bit about the move from reactive firefighting to proactive prevention, and how do we make sure that our AI agents learn over time and learn how to
Yeah.
prevent some incidents after they've encountered them a few times already?
I for sure think as well that the future is pretty bright with Gen AI and like agentic approach to fixing issues. And I think if today we have, for example, AI SRE that, like Neil said in the previous slide, we basically have good triggers that tells us something is not working properly. So that's what triggers us to investigate and remediate the problems. And I think that in the future, the goal will be to predict and prevent them from happening in the first place, right? So the agent might be constantly monitoring, and we have a lot of data, and be able to notice a pattern before it becomes an outage. And so with what you said also, Neil, that it will learn on its own, right, and expand its context, it's even more it makes even more sense because it will learn from previous things and will notice how it can detect certain patterns even more efficiently. So it can fix them before they happen. And it just can give you like a notification or like a report every week and tells you, listen, I fixed this and this while we were asleep. So, continue sleeping. That's good. And like, I'm happy for that. Being on call
In the
and
morning and just getting the fix,
yeah,
the report of what happened in the night.
I know that anyone that's been on call knows for sure that waking up in the middle of the night to troubleshoot something you have no idea about is one of the most frustrating feeling there is. But you do it because you have to. And I really hope we can kind of move from being the firefighter, right, to someone that can architect that system of agentic AI that will fight this fire for us, right? It's a bit like life, right? You have kids so they can continue and make the world better than you did. It's a weird analogy, but that's the way I see it.
Yeah.
Well,
I will say just one more thing about trust. I think in the future we will have more trust.
Yeah.
So we had also a question from the crowd about how we make our agent not mess up, right? So I think it's a trust issue that is going to be better and better in the future, and we will delegate more and more tasks to them when we feel that we have trust that they're going to do a good job, and we have those guardrail. Maybe we'll have a better guardrail than what we have now. Yeah.
Okay, so sounds like you're optimistic about the future, which is good. And I think we will conclude on this positive note. We have a couple of questions, but we already went over time. So if you have any more questions, feel free to reach out to myself or Mikael or Nir. You can find us on LinkedIn. If you want to see what we've been talking about in real life, and see Klaudia AI SRE in action, you can check out our website at komodor.com. We have a 2-week free trial that you can sign up to. And talk to us, share your thoughts, share your experience. And with that, we will conclude. Thank you so much, Mikael and Nir. It's been a super interesting discussion. I hope everyone who joined us enjoyed it as much as I did. We will, like I said at the start, we will share the recording and highlights of this conversation with everyone who registered. So if you missed anything or had to go debug an incident while you were listening, so don't worry, we will cover everything for you. And that's it. So thanks everyone. Thanks Mika, thanks Nir,
Thank
and
you.
we'll see you next time. Bye bye.